Hello and good morning to all. I am Vikas. Today we will going to cover one more topic related to the first unit, that is minimization of finite automata. So in the minimization of DFA, deterministic finite automata, DFA consists of some redundant state, that is state whose function can be handled by other state. So in a DFA, there are more than one states are there, or there are some states are there whose states will going to perform same operation. So instead of keeping all those state as it is, we can reduce those state into a single state whose function, whose task is same. So now what do you mean by minimization of DFA? So here minimization of DFA is a process of constructing an equivalent DFA with minimum number of states. Means we have to reduce those states whose function is same. We have to reduce those states into a single state. Suppose 4 states are there which will going to perform same operation. So instead of keeping those 4 states separately, we are going to combine those states into a single state. So in simple word, minimization of DFA is a process which will construct an equivalent DFA with minimum number of states. Now we'll consider one example, and with the help of example we'll see how to minimize the DFA. Here in this example total 8 states are there, that is Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. So Q0 is the initial state and Q2 is the final state, because in the transition diagram which is shown by using double circle. Now there are two input alphabets are there, 0 and 1. So we'll see one by one how to minimize the given DFA. So in first step what we need to do? In first step we need to find out partition 0, that is P0. In that we are going to divide the given state, given number of state into two blocks, such that one block consists of set of final state, another block consists of set of non-final state. So here in the given transition diagram you can see Q2 is the final state and all remaining, that is Q0, Q1, Q3, 4, 5, 6 and 7 are the non-final state. So we are going to divide the given number of state, that is total 8 state, into two blocks, such that first block will consist of set of non-final state and second block will consist of set of final state. So here we have performed two blocks in a partition P0, such that Q0, Q1, Q3, Q4, Q5, Q6, Q7 is in one block and Q2 is in another block, and we have renamed those blocks as a block 1 and block 2. You can rename it with any name, that doesn't matter, like B1, B2 or B0, B1 or any other. Here I have specified that name as a block 1 and block 2. Now in a second step, we need to find out partition P1 on equivalent 1 under any input sequence length 1 on input 0 and 1. Is what we need to find out on input 0 transition on input 1, where that block 1 or block 2 will map. Here you can see block 2 consists of single state. There may be the case we may have more than one final state, but here in the given transition diagram there is a single final state is there, so no further partitioning is possible for this block. Okay, so no need to check for block 2, but in a block 1 total 7 states are there, that is Q0, 1, 3, 4, 5, 6, 7, total 7 states are there. So we have to divide that block into equivalent state. So here total 7 states are there, we have to check whether any 2 state through 3 state will going to perform same operation or not. So for that what we are doing, we are finding its delta transition with the help of given transition diagram. Here you can see on input 0 delta transition is what? So delta Q0 on 0. So Q0 on 0, here you can see it is in Q1. So Q0 on 0, Q1. Same way Q1 on 0, Q1 on 0 it is in Q6. Q3 on 0, Q3 on input 0 it will be in Q2. Same way Q4 on 0. So we have find out like this, it is in Q7. Q5 on 0, Q5 on input 0 it will be in Q2. Q6 on 0 it will be in same state, means Q6, and Q7 on 0 it will be in Q6. So we have written on input 0. Same way on input 1, so Q0 on 1, So Q0 after accepting one input it will be in Q5, Q1 after accepting one input it will be in Q2, Q3 after accepting one as input it will be in Q6, like this Q4 on one, Q4 after accepting one Q5, Q5 after accepting one Q6, Q6 after accepting one as an input it will be in, you can see here Q4, and Q6, Q7 after accepting one as input it is in Q2. So here we have find out on input 0 transition as well as on input 1 delta transition. Here you can see Q0 after accepting 1 it is in Q1. So Q1, Q6, Q7, Q6, Q7. Okay, sorry, Q6. So all these are mapped into the block 1. You can see partition 0 in that block 1 having consist of all Q0, 1, 3, 4, 5, 6, 7, but in block 2 Q2 is there. So on input 0, Q0, Q1, Q4, Q6 and Q7 are mapped into the block 1. Here are mapped into the block 1. But on input Q3 on input 0 and Q5 on input 0 it is mapped into the block B1 or block 1. Why? Because here after taking 0 as input it will be in Q2 and Q5 also it is in Q2, and Q2 is in another block. Q2 is in another block. That's why on input 0 Q3 and Q5 are mapped into block 2 on input okay, and all remaining state are mapped into the block 1. So that's why Q3 and Q5 are different than the state Q0, Q4 and Q6 as well as Q1 and Q7. But on input 1 you can check here, on input 1 Q1 and Q7 are mapped into the different block, that is on block 2, but all remaining state, that is Q0, 3, 4, 5 and 6 are mapped into the same block, that is on block 1. Okay, that's why on input 1 Q1 and Q7 are different, are mapped into the block 2, and on input 0 Q3 and Q5 are mapped into the block 2. That's why on input 0 Q3 and Q5 are different than all remaining state, and on input 1 Q1 and Q7 are different than the remaining state such as Q0, 3, 4, 5 and 6. So that's why block 1 from this partition P0 will going to divide it into number of blocks such that Q3, Q5 are in one block, after that Q1, Q7 are in another block, and remaining state Q0, Q4, Q6 are in another block, and Q2 which is already in different block. That's why in a P1 we'll get total 4 blocks, that is first block, second block, third block and fourth block. First block consists of Q3, 5, second block consists of Q1, Q7, third block consists of Q0, Q4, Q6 and fourth block consists of Q2. So here, so P1 partition will become like this after on input 0 and 1 in a partition P1. So P1 partition will become like this. So we have renamed these as a block 1, 1, 1, 2. So why 1, 1, 1, 2? Because here partition 1 is there, so we have renamed it as 1, 1, 1, 2, 1, 3, 1, 4. Again, it is not necessary you have to use the same name. You can use B1, B2, B3, B4 like this as well. That doesn't matter. Now we need to find out the partition P2. Okay, on input 0 and 1. So in a partition P1 there are 4 blocks are there. Okay, but for Q2 no further partitioning is possible. Why? Because there is a single state. But we have to check whether these two state are identical, or we need to divide it into 2 different states or not. Like this second one, third one. So we'll now consider the block 1, 1. That is Q3, Q5. So on input 0 and 1. So already we have find out its transition, right? Q3 on 0. So Q3 on 0 it will be in Q2, and on 1 it will be in Q6. So here we have written Q3 on 0, Q2, on 1 Q6. So same way on Q5 on 0. So Q5 after receiving 0 as input it will be in Q2, after receiving 1 as input it will be in Q6. So here you can see Q2 is in one block. Okay, so both Q3 and Q5 on input 0 it is mapped into the same block. So on input 0 that 2 states are identical, but we have to check on input 1 whether that 2 states are identical or not. So Q3 after reaching 1 it is in Q6 this block, and Q5 after reaching 1 Q6 means both states are mapping into the block 1 3. I am not saying that in same state, I am saying that in same block. That's why that two states are identical on input 1. Here even if Q3 after reaching 1 it is in, let us say, Q0, and Q5 after reaching 1 it is in Q6, but Q0 and Q6 both are in same block. That's why still that two states are identical on input 1. So here on input 0 that are mapped into the 1 4 means both states are mapped into the block 1 4, and on input 1 both states are mapped into the block 1 3. Okay, that's why that two states are identical. Now so this block is identical, no further partitioning is possible. Now we have to check for Q1 Q7. So here for Q1 and Q7 we have find out delta transition on input 0 and 1. So Q1 after reaching 0 it is in Q6. We have find out it with the help of transition diagram. So Q1 on 0 it will be in Q6, Q1 on Q7 on 0 it is in Q6. Same way Q1 on 1 it is in Q2, and Q7 on 1 it is in Q2. So here you can see Q6 is in one block. Is both states after reaching 0 input it is in same block, mapping into same block, and Q1 after reaching 1 and Q7 after reaching 1 mapping into the same block. I am repeating, I am not saying that in same state. Actually here it is in same state, that doesn't matter, but even it is in same block, still we can say that that two states are identical. So on here on input 0 Q1 and Q7 are mapped into the block 1 3, and on input 1 Q1 and Q7 are mapped into the block 1 4. So as both states on input 0 and 1 are mapping into the same block, therefore that two states are identical. On 0 both two states are mapped into the same block, on input 1 are mapped into the same block. Okay, that's why that two states are identical, no further partitioning is possible. Now we'll check for block 1 3. So now in a block 1 3 there are three states are there, Q0 Q4 Q6. So Q0 on 0 it will be in Q1, Q4 on 0 it will be in Q7. So this we have find out with the help of given transition diagram. So given transition diagram you can see Q0 after reaching 0 it is in Q1, Q4 after reaching 0 it is in Q7, and Q6 after reaching 0 Q6. So like this we have find out, and we have written here. Okay, Q1 Q7 and Q6. Same way Q0 after reaching 1 it is in Q5, Q4 after reaching 1 it is in Q5, and Q6 after reaching 1 it is in Q4. So here you can see Q0 after reaching 0 it is in Q1. So here Q4 after reaching 0 Q7. So that two are in mapped into the same block 1 2. That two are mapped into the same block, that is block 1 2. But Q6 after reaching 0 it is mapped into the block 1 3. It is mapped into the block 1 3. So that's why state Q6 is different than Q4 and Q4 on input 0, but we have to check on input 1. So here you can check Q0 after reaching 1 Q5 is in block 1. Okay, block 1 1, and Q4 after reaching 1 it is in Q5. So block 1 1 it is mapped into block 1 1, and Q6 after reaching 1 it is in block 1 3. So here you can see, okay, on input 1 Q0 and Q4 are different than Q6 because it is mapped into the block 1 1, and here it is mapped into the block 1 3. So here on input 0 Q0 and Q4 are mapped into the block 1 2. On input 1 Q0 and Q4 are mapped into block 1 1, but state Q6 are mapped into different block 1 3 on input 0, on input 1 mapped into the block 1 3. Therefore state Q6 is different than Q0 and Q4. Therefore block 1 3 is divided into two blocks such that Q0 and Q4 is in one block and Q6 is in another block. So we have written P2 partition with the help of this. So P2 partition will become like this. Previously you can see P1 having this is in one block, but in P2 these two states are identical, so we have written in one block. These two are identical, so these two are in one block. These two we have divided that Q0 Q4 Q6 into two different blocks, Q0 Q4 and Q6. Now in a partition P3 we have to find out equivalent 3 on input 0 and 1. So in a block 2 1 that two states are identical, already we have find out. Q1 and Q7 is also identical on input 0 and 1. But now we have to check Q0 and Q4. Okay, and Q6 is a new block. But here in a block 2 core there is a single state, no further partitioning possible. So we have to check only for Q0 and Q4. So Q0 after reaching 0, again with the help of given transition diagram. Okay, Q0 on 0 it will be in Q1, and Q4 on 0 here it will be, okay, I'll check Q4 on 0 it will be in Q7. Okay, here it will be Q7. Okay, Q0 on 0 Q1 and Q4 on 0 Q7, same way. So Q1 and Q7 is in same block. So on input 0 that two states are identical because it is mapping into the same block. But on input 1 Q0 on 1 Q5 and Q4 on 1 Q5, so it is mapped into the same block on input 1. So on input 1 and on input 0 that two states are mapped into the same block, therefore Q0 and Q4 are identical. So now therefore P3 is equal to P2, which is equal to Q3 Q5 Q1 Q7 Q0 Q4 Q6 Q2. So no further partitioning is possible. So in a given transition diagram there are total 8 states are there: Q0 Q1 Q2 Q3 Q4 Q5 Q6 and Q7. But here now in a minimized DFA we are getting only 1 2 3 4 and 5 states, because these two states are identical. So we are going to consider this one is single state. Same way these two states are identical, so we are going to consider this is another state, second state. This is third state because these two states are identical. This is fourth state and this is fifth state. So we have minimized total 8 state into 5 state. So now we'll draw transition table with the help of the states. So here you can see Q1 2 3 4 5. So now so here we have written Q0 Q4 is the initial state in a given transition diagram. So here Q0 is the initial state in a given transition diagram. Okay, Q0 is the initial state in a transition diagram and Q2 is the final state. So the block which consists of Q0 will become initial state in a minimized DFA transition table. That's why Q0 Q4 is the initial state. So I have shown it with the help of arrow. Same way second block is Q1 Q7. So this is another state. Q3 Q5, this is third state. Q6 fourth state, and Q2 is the final state in a given transition diagram. So here also in minimized DFA transition table we have shown it by using star because it is final state. Now Q0 Q4 after reaching 0, Q0 Q4 after reaching 0, where it will be? So Q0 Q4 after reaching 0, Q0 after reaching 0, here you can see Q1. Okay, Q0 after reaching 0 it is in Q1 and union with Q4 after reaching 0 it is in Q5. Okay, if we will take the union of Q1 and Q5, so we will get it as a Q1 and Q5. So that's why Q0 Q4 after reaching 0, Q0 after reaching 0 it is in Q1 and Q4 after reaching 0 it is in Q7. So if we will take the union of Q1 and Q7, we will get Q1 and Q7. So that's why here we have written it as a Q1 and Q7. Same way Q0 Q4 after reaching 1, Q0 Q4 after reaching 1. So Q0 Q4 after reaching 1, Q0 Q4, Q0 after reaching 1 it will be in Q5, Q4 after reaching 1 it is in Q5. So here you can see it is in Q5. So we need to write down Q0 Q4 after reaching 1 it is in Q5. So in a transition table we have written Q0 Q4 it is in Q5. Okay, it is in Q5 only, not in Q3. So here it will be only Q3. Like this you need to build the transition table. Q1 Q7 after reaching 0, Q1 Q7 after reaching 0. So Q1 Q7 after reaching 0, Q1 after reaching 0 it will be in Q6, and Q7 after reaching 0 Q6. If we will take the union Q6 with Q6 we will get Q6 only. So that's why here we have written it as a Q6. Same with Q1 Q7 after reaching 1, Q1 Q7 after reaching 1. So Q1 Q7 after reaching 1. So Q1 after reaching 1 it is in Q2, Q7 after reaching 1 it is in Q2. So that's why we have written it as a Q2. Okay, so like this. Now this is the transition diagram, and with the help of this transition diagram we need to draw the with the help of this transition table we need to draw the transition diagram. So Q0 Q4 after reaching 0, where it will be? Q1 Q7, Q0 Q4 after reaching 1, it will be in Q7. So okay, Q0 Q4 operation 0, it is in Q1 Q7. so here you can see on the on 0 Q1, yes, Q0 Q4 operation 0, it will be Q1 Q7. so here we have shown it is in Q1 Q7. On input 1, Q0 Q4 operation 1 Q3, actually it is in Q3 only, so it is in Q3 Q5 block, so it will be in Q3 Q5 block. Q1 Q7 operation 0 Q6, Q1 Q7 operation 0, it is in Q6. so here I have shown same way. Q1 Q7 operation 1, it is in Q2, so Q2 is the final step, so it is shown by using double circle, and now it is in Q2. Next Q3 Q5, it's one block. On it 0, it will be in Q2. On input 1, it is in Q6, so we have shown it. Q6 operation 0 Q6, so same step. Q6 operation 1 Q0 Q4, Q6 operation Q1, it will be in Q0 and Q4. so yes, we have shown like this, so it is in Q4, right? And Q2 operation 0 Q2 operation 0, it will be in Q0 and Q4, okay? And Q2 operation 1, it is in Q2, so it is in Q2. so we have drawn the transition diagram. This is final minimized transition diagram. so here you can see only 5 states are there. In previously we are in total 8 states are there. So these 2 states will perform same function, these 2 states will perform same function, like this. So in a minimized DFA we are having 5 states. So this is the procedure, this is the algorithm. With the help of that we can minimize the given DFA. So try to solve this problem. Here total 8 states are there, and Q3 is the final state, Q0 is the initial state. So try to solve this problem. Thank you.